First entry of the year is going to be on solving one-step equations. Now, this should be familiar to you because you should have done it last year, but it's nice to review. In the packet that you got from the bin should be this handout of inverse operations and a blank white piece of paper for us to do our examples. We're going to start by cutting this inverse operation in half because we only need one part of it. Before we talk about inverse operations, let's talk about equations in general. So we'll put this aside. Let's say you have just simple 3 plus 4. And 3 plus 4 is equal to 7. Now you have 3 chickens and 4 chickens is the same as 7 chickens. Now, you could also say that 3 plus 4 is equal to 2 plus 5. If you have 3 chickens and 4 chickens, it's the same as having 2 chickens and 5 chickens. So as long as two sides of an equal sign are the same, right, they're equal, we can change the way it looks. And this is especially going to be important when, let's say, we don't know how many chickens we have, and we're trying to figure that out. In order to solve an equation for a variable, like this variable x, we're going to use inverse operations. So before we do that, let's talk about what those are. So the 3 operations I want to talk about are addition, which is represented by a addition symbol, right? Looks like a T almost, like a plus. Multiplication, which is for this one just A times B, where, I mean, it could be 2 times 3 or 6 times 8, but we just use letters here. And then the third one is when we multiply using fractions. So like 3/4 times something. So inverse means opposite. So what would the opposite of addition be? That would be subtraction. So you're going to write subtraction here. And then in red, nice big subtraction symbol. The opposite of multiplying by a number would be dividing by a number. So that would look like A divided by B. And you're going to write divide on the top. Now this is when we multiply by fractions. Now the opposite of multiplying by a fraction is to multiply by the reciprocal. And the reciprocal of 3/4 is 4/3. So those are the 3 inverse operations that I want you to know for now. So now let's go over recognizing when we have to use addition, subtraction, and multiplication. When you have addition, you're going to see a positive number by itself. For example, this 3 is positive, as the plus symbol, and also if it's written this way, the 3 is also positive. Recognizing subtraction, when you have a term with a negative sign in front, like this negative b here, b could be any number like x minus 3, x minus 4, or the negative could be right here. So both of those means you're subtracting. And then lastly, to recognize multiplication, it's when you have a number and a variable that are side by side. So that's going to be the 6 next to the x. It means you have multiplication. And when you see this in an equation, we're going to use the inverse operation. So when you see addition in an equation, you're going to want to use subtraction to solve that equation. When you see multiplication, you want to use division, and so on and so forth. Now you're going to tape this inverse operations handout into your book. You're just going to take one piece of tape, and you're going to kind of put it towards the side, and you're going to stick it right on this side so that it flips open like a book. Just like that. Because we're going to do examples on this side of solving one-step equations using inverse operations. So these are the 6 examples that we're going to solve together. We're going to do it step by step. What I would do now is you can pause the video so you can write these down, because I'm going to zoom in the camera for each one so it doesn't look so far away. So you can pause this and then copy this down just as I have it here. Again, it's going to be part of the foldable, so you'll flip that, and then when you flip it open, we have these examples here. Our first example, we have x minus 7 equals negative 6. Now I did x in a different color because I want it to stand out, and I want it to be seen that we're solving for x. We're trying to get x by itself. So the first thing you have to ask yourself is, what is happening to the variable? So we have x minus 7. So what are we trying to recognize here? If you flip open your chart, you'll see that you recognize subtraction. And if you want to solve for x, we do the inverse of subtraction, which is addition. So we're going to add 7 to both sides here. And I do it right, kind of top to bottom. What happens is negative 7 and positive 7, those cancel out. And we're left with x is equal to negative 6 plus 7 is positive 1. So x equals 1. And you can check your answer here. We think x is 1. So we're going to plug that into our equation. Does 1 minus 7 equal negative 6? 1 minus 7 is negative 6. So it does. Now you can check for these simple one-step equations. Sometimes you don't have to. You definitely want to check when you start to get to multiple step equations and equations with variables on both sides, because there are more steps and more opportunities to make mistakes. So let's move on to example 2. Here it's y plus 3.4 equals 0.5. What you should recognize here is addition, so we want to subtract. Subtract 3.4 from both sides. And 0.5 minus 3.4. Y should equal negative, right? Because 0.5 is smaller than 3.4. It should be negative 2.9. Example 3 is a little bit of a curveball, but not really. You notice that we have the symbol pi. It's h plus 2 pi equals 3 pi. Now pi is just a number, so we can treat it as just a number. 2 pi is still just a number. It just means we have pi twice. 3 pi is you have pi 3 times. Right? But we're not trying to solve for pi here. We know that it's 3.14, 159, and keeps going. What we're trying to do is solve for h. So what do we recognize that's happening to h? You see we're adding 2 pi. So we want to subtract 2 pi. And by doing that, we get the h by itself, because those cancel out. And h equals, if you have 3 pi's and you take away 2 pi's, you don't have just 1, you have 1 pi. Okay? It's important to remember that. We don't just get rid of the pi. Right? You have 3 pi's, you take away 2 pi's, you still have a pi left. Example 4, we have 14x equals 42. Now, what do you recognize happening to the x here? Multiplying by 4, right? So we're going to multiplying by 14, so we're going to divide by 14 on both sides. And when we do that, 42 divided by 14, because those cancel, is equal to 3. So x equals 3. Example 5, we're solving for n. It's n divided by 7 equals 3. Now you notice that we have division here because we have a fraction bar. The opposite of division is multiplication. So I'm going to multiply both sides by 7. 7 over 7, those cancel, and I'm left with n equals 3 times 7 is 21. So in all of these examples, you've noticed that I've done the same operation to the left side that I did to the right side, and vice versa. Now that's important because we want to have balance when we have something that that is equal, because if we do something to one side and not the other, they're no longer equal. Now let's move on to example 6. For example 6, we have negative 3/4 x equals negative 12. Now you recognize that we have a number next to a variable, they're side by side, so we have multiplication. But this is kind of a tricky multiplication because we're multiplying by a fraction. And when you multiply by a fraction, you have both multiplication and division, right? Because you have a fraction bar here. So how do you get rid of that? Well, if you look at your inverse operation page, when you are multiplying by a fraction like 3/4, the inverse of that would be to multiply by the reciprocal, which is when you flip the numerator and the denominator. So that's what we're going to do on example 6. So in your book, I want you to write, to get rid of the fraction, we're going to multiply by the reciprocal. And the reciprocal of negative 3/4 is negative 4/3. So we've got this equation, negative 3/4 x. I'm going to keep x in purple, equals negative 12. And I'm going to multiply both sides by the reciprocal. So that's negative 4/3. So let's see what happens when we have all this math going on. 4 divided by 4, right, because we're multiplying these. Those both cancel to 1. 3 and 3, those both cancel to 1. And a negative times a negative is a positive. So all we have left here is 1x. And that equals, well, we have negative 12, and then times negative 4, which would be positive 48, divided by 3 would be positive 16. So our answer here would be 16. Now that you've finished the notes portion, you're going to move on to the practice in the textbook.